Out in this field, there are hundreds of wires buried underground. Technicians use soldering and even thermite to build these ground systems. This is one of the most important parts of an AM broadcast tower, and you'll probably never see it. My dad and I had the opportunity to talk to someone I nicknamed the Ground Whisperer, and like many who deal with high-power AM radio, this guy had some stories.
There was a nursery next door, and the operator of the nursery called the station one day and said, "Y'all gonna do something? My violets won't go to sleep."
This is Kevin Kidd. He has been called in on many interesting projects over the years. Ground systems, he has a company, AM Ground Systems. We think there's plenty of information here that you'll be interested in.
What we have here is the base of an AM radio tower. Obviously the tower going up. The cone-shaped device there between the bottom of the tower and the concrete is actually a ceramic insulator. That entire tower is being supported by that insulator. Yep. And big towers like well, KMOX or the WLW tower or WSM in Nashville, yeah. They same deal. Yeah. They have an enormous insulator under them.
And you know the KSD towers have the four-legged guys. Mm-hmm. They have one on each leg, so that's another thing.
Actually, they have two. On the base of a self-supporting tower, you have the tower is sitting on mm-hmm. an insulator similar to this, mm-hmm. but coming up through the center of that, there's a enormous bolt, and there's another insulator similar to that sitting on top of it with a cap on it that actually is holding the lifting pressure.
I'll be darned.
So those are torqued down and holds the tower up straight.
Yeah.
And then
I think I have a picture when the towers fell over from being in the field and seeing one of the legs popped up, and it had a big, it might have been a bolt or something, a piece of something in the middle. Generally
it's a big bolt goes mm-hmm. all the way through the bottom insulator, through the leg, yep. and then through the top insulator. You notice that the insulator has the top of it is aluminum, the bottom of it is aluminum, but it's all ceramic in between. Some of these are hollow, some are not. Mm-hmm. Some of them are empty, some are oil filled. Mm-hmm. Some of them are cone shaped like this, some are just a cylinder. It all depends on the manufacturer, but the straps going up the outside of it is grounding the base of the insulator. And not only does that provide the path to ground for the arc gap, helps to dissipate a lightning strike before it actually does any damage in the building. Mm-hmm. And notice this one's spaced about 1/4 of an inch or so, mm-hmm. depending on the power of the station. Mm-hmm. They can actually be usually much closer than you would actually think mm-hmm. Before they arc over from mm-hmm. the transmitter. Mm-hmm.
You know how, and that would that affect the impedance, wouldn't it, of the transmitter if you get too close?
Some, but the problem you run into, you may adjust it and it'd be perfectly fine with the transmitter on, but you have a lightning strike, mm-hmm. it arcs across, and then it's close enough that the transmitter actually will maintain the arc.
That's
the next thing that happens is the arc gap balls fall off and you have no more arc gap. These are solid steel. They're welded. They're just a large steel ball bearing. Mm-hmm. Some of the arc gaps you see are a hollow aluminum ball that's threaded, and it just threads down onto a piece of copper tubing. Mm-hmm. They will literally just melt and mm-hmm. fall off. Mm-hmm. These probably not. When it actually arcs between them, for that instant that it is arcing, it's basically a dead short ground. Mm-hmm. And many times you'll see VSWR faults on transmitters mm-hmm. after a lightning strike. Yep. The strike's not what caused it, it was the arc that caused it, mm-hmm. because briefly the tower was shorted to ground.
Could it also be from a hot dog sometimes?
Yeah. Made a huge difference in my life. In his document, Dignitatem on the dignity of vocation of women. Says
that now we're standing on top of probably 120 radials going out. These straps go down the side of the pier and connect to a strap that goes around the perimeter of the pier. Mm-hmm. Generally, that's only, sometimes it's on the surface, sometimes it's feet deep. I'm glad to see that this one is not. But the radials come up and are bonded to that perimeter strap. Now from that perimeter strap, this strap you see coming out of the bottom of the tuning unit over here, that should come over and connect to the perimeter strap. And then there should be a buried strap, and we would hope it would be several feet deep, just to keep somebody from finding it, that goes either from here to the other towers or from here to the building.
So it sounds like there's a lot going on. My dad wanted to know, what does Kevin think is the most important thing in a grounding system?
Well, what are the most critical things you think about the ground systems in general to get that signal out?
The main thing you want to do is make sure that all grounds are ground, that they're all the same ground. You should have station ground. All of the grounds should be tied to station ground. It's a little contrary to National Electrical Code to actually achieve the best stability and protection for the equipment. Because with a neutral and a ground, and I'm not abdicating for that, but if you have a neutral and a ground, that's two different grounds. Those grounds, to give best RFI protection, RF protection, and lightning protection, really need to be the same ground. But that's to comply with National Electrical Code, you can't do that. So actually all grounds need to tie firmly to station ground. I've found my own clients that would have a lightning problem, and we're going to drive a ground rod outside right here and connect this console to it. Well, the lightning problem gets worse. The lightning actually hits the tower or power or whatever, goes to that ground rod, radiates out through the ground, and now they have just driven an antenna down here to pick up that energy.
Oh, wow.
And instead of it actually, the idea is that you bring all grounds to the same level at the same time, so there's no difference in potential.
Look outside any building with electrical service. You'll probably see a ground rod somewhere providing a safety ground. With AM radio, you actually need multiple ground rods, and it can be difficult to determine exactly how many and where to put them.
I don't know that anybody's figured out the exact correct way to calculate 6 ground rods, 3 ground rods, 10 ground rods, but I've seen a bunch of different configurations. I assume you have too.
Well, many. A ground rod that is at least less than its own length, that is closer than its own length to another ground rod, it's not hurting anything. Not going to hurt anything, but it's not going to achieve any extra dissipation of the energy into the ground. They need to actually, according to Polyphaser and others, they need to be about twice the distance, the length apart. If you got an 8-foot ground rod, they need to be about 15 or 16 feet apart. The bonding is probably 90% of the problems that I find with AM ground systems is actually workmanship. People use the incorrect solder. Just go to the hardware store, get some acid core solder, go build your ground system, cover it up.
Don't do that.
The lifespan of just plain hardware store acid core solder below grade, except maybe in the desert, is probably months. You could have a perfect ground system, but nothing's connected to each other.
The question that was burning in the back of my mind ever since seeing that Camo X diagram was, why do AM tower sites have so many radials?
Well, first off, the FCC says you have to. There is one radial is better than no radials. 120 radials, which is a standard ground system, is quite a lot better than one radial, but probably not as much as you would think. I think I have the story right that back in the 20s, when most of the AM research was being done, they put in the paper that was written on it. I think they said they at 118 radials had saw no discernible difference between 118 and 112, whatever their last number was. And someone asked, why did you stop at 118 radials? And said, we've run out of wire.
So much for that test.
that was the reason they stopped at 118.
Yeah, and from a practical perspective, also, some radials are going to get broken or busted, or some of your joints are going to be bad. So having an extra number higher than you needed for efficiency makes sense it's much cheaper to do it all at once than to come back and wish you had them.
4 radials is what a lot of ham antennas have. You are actually approaching not necessarily maximum efficiency, but a very easily achievable level of efficiency just with 4 radials. A lot of elevated ground systems only have 4 or 6 radials, sometimes 8, very seldom ever more than 8. A in-ground ground system is specified as 120 for an AM broadcast station. Many AM broadcast stations have at least 120. Some, like we were talking about KMOX, I think it's actually got 240 full-length radials. Almost all AM stations have either screen around the tower bases of some size, usually 24 by 24 for the higher frequencies and 48 by 48 for the lower, or interspersed radials, a long radial, a short radial, long radial, short radial. Usually those short radials are about 50 feet long.
Where have you seen the worst damage that created signal issues for a station?
Generally vandalism. That's accidental things. Generally is a backhoe or a trencher or whatever, but some of the worst damage is it's always vandalism. I've had several that have been accidentally damaged, usually by a cable contractor coming in. The last telephone pole's there, another business is over there.
Coming and digging holes.
They just go straight across. That has actually happened. And actually I've had some with multi-tower arrays actually plowed. They dug through the transmission lines. That's a bad day.
I also wanted to know if there was an ideal depth to bury radials, and also what might happen when you short a tower through a hot dog straight into ground.
Where does the energy go when we short that hot dog into the ground? Like, it goes in the ground, but what does that mean? And if you had the copper lower in the ground, would that be better? Or sand versus soil, or, you know, that kind of...
It depends on the soil. And now there again, the physics of all that is way above me. In normal soil, most ground systems are 4 to 6 inches deep. Deep enough to keep it from coming to the surface and being damaged. Generally, you don't want to go deeper than that, but in certain soil conditions, you can go many feet deep and not lose any efficiency. Once you, most soil, once you get below about 6 inches, then supposedly you start seeing a drop-off in efficiency of the system. But as I understand it, I've never built one that was deep. But in the Midwest, there are some ground systems that are 5 and 6 feet deep, just for tillage. From what I understand, the better the ground conductivity, as in the AM signal conductivity, which is all in the Midwest, this area has good ground conductivity. It can be deeper than, say, in Tennessee, where I'm from. We have ground conductivities in the 0.5s. 4 to 8 is, I think, normal for my area. Here it's probably, what, a 15 or higher.
What are the main things, like you're at a facility now, you want to test how good does this ground system appear to be?
Well, there's several questions that I normally ask. How stable is it? Having lightning problems? Has there been any known vandalism or damage? That actually is one of the best places to start. But honestly, the Mark I eyeball is one of the best tools. As we're going to do here, digging around the towers and actually doing a visual inspection of the bonding around the bases, checking, make sure that the tuning unit is tied to the tower base strap. And as we're questioning here, is there a piece of strap bonded there and coming back to the building?
Now, and what kind of tools would you have? Do you have something you clip on here and you can run the radials out and detect it?
Several different things. I have a couple of cable locators that we'll be using to run these out. I have, and I didn't bring it with me, I actually have a radial chaser, as they're called, that is nothing more than a little field strength meter on a stick. It just picks up the RF off of the radial itself, the current flowing in the radial. One of the ones I made just used a typical voltmeter, and you could read the voltage off of it. Hey, that's cool, I can tell how much current's flowing. Have you ever tried walking across a field like this, swinging a stick around and trying to read a voltmeter and then not fall down? So I went back to the headphones.
Well, the depth of them, so like they may leave here at 6 or 8 inches, but at any time, because of tractor driving or anything, it would push those down, and then stuff going over the top. So you go down, at some point you wouldn't be able to detect it even though it's there? Or
no, it's like, well, with the cable locator, if I'm putting, the cable locator actually injects a signal of its own. I can either trace an existing, the RF that's on it in most instances, or I will actually put RF on it from the generator that's part of the the cable locator.
Now you do that, you have to have the station off to do that. So you can do that, you can inject that in there. And for most of us, our radio guys, like, well, we're injecting into a wire that's buried into the ground. It just doesn't sound real. It's like, that just is the worst.
It's exactly the same thing the power companies and phone companies do when they're tracing buried cable.
And so you can go several feet under? Or?
Wow. Well, anytime you're doing it inductively, as in just setting the generator on it, that's what it's meant to do. Now you're limited to a foot or two at that, but I also have a clamp, looks like a large amp clamp, that I can actually clamp either around the individual wires or around the strap that's going around the perimeter strap, and then trace that signal out. One of my cable locators runs at, I think it's something like 80 kilohertz, and just a little green Lee cable tracer.
We've talked a little bit about guy wires, but there's insulators. Like, why are there insulators? And also, how do they affect the ground system? Because they're long wires that are, I guess, floating? I don't know.
Yeah, well, as a matter of fact, they are floating. The insulators and guys, if the guy wires were not insulated, if it was a steel wire, that would be shorting the tower to ground at multiple points. And yes, I actually did arrive on a site quite a number of years ago where somebody had built a tower for AM and had not put insulators in the guys. And we were going to be building a ground system for it, and the engineer, the local engineer, had called me and said, this thing just won't load up. He had been trying to get a ATU built for it, and they actually had a little power into it. But he had just had to cobble this horrible, massive ATU together, and it measures crazy. And when I got there, I said, well, you ever look at your guy wires? There was no insulators in them. So anyway, the tower crew, as it turns out, they had bought. The tower crew just didn't know what they were there for. They were in a drum. They had bought the kit with the insulators. Tower crew just hadn't put them in.
And I've seen a lot of towers where they insulate heavy, like they'll put a 3 foot or 6 foot fiberglass rod just to keep it off there. So keep the cable off the tower. I don't know if that's for arcs or what.
For arcs, and of course a lot of FM towers have those in them up in where the aperture of the FM antennas would be. These insulators are actually spaced at a non-resonant length along the guy wire, just to keep the wires themselves from becoming part of the antenna system.
We talk about grounding and everything else, but the ultimate point is to get the signal to the listeners. But I've always said, it's like, if I could remove the last 20 years of industrial growth and home building and bridge building, that would get my signal a better kick than fixing the ground systems.
Would it be a good idea to build a neighborhood right around the base of a tower? Would that help the grounding or hurt the grounding?
Hurt.
Would that help the people living around it?
Unaffected.
Unless they have a toilet that talks about the radio station.
I've actually had several. Well, built a 10 kilowatt site a number of years ago, and there was a nursery next door. And the operator of the nursery called the station one day and said, "Y'all going to do something? My violets won't go to sleep." And well, my mother had grown violets, so I know that they you turn the lights on so many hours a day and off so many hours a day. It wasn't the fact that the lights were staying lit. It was the fact that his timer was unreliable. It apparently was coming on and going off. And we actually helped him get another timer and did a little grounding and solved the problem. But his violets wouldn't go to sleep.
And what about, so you talk about the bonding piece. So I've seen, what's the flame bond? Cadweld. Cadwelding, thermonuclear bonding, I call that. But maybe it's not quite that. But,
no. Exothermic.
Even the cadwelds, like I've seen them on poles around fence posts and things like that, and I've seen them separate, but most of them hold very well. But like the artistry part of that, or the learning part of that, like where do people get that? Do you guys go to the training sessions at CAD welding companies?
There are training that either the CadWeld company, whoever owns them now, UltraWeld, there's 2 or 3 different companies make those now. And yes, there is training. It's actually pretty simple. There's, of course, lots of stuff on YouTube and people doing dangerous things with it on YouTube. But the difference between the bonding that we do around a AM tower, which is brazing, using a silver called Silphos, silver, copper, main ingredients copper. It's got some silver and phosphorus in it. It actually is just a filler metal, just like solder. Just as if you were soldering something onto a circuit board, the solder is the filler metal. Whereas with the exothermic, it's actually melting. It is melding those together. They become one piece.
And I know my first experience with that was if the copper gets too hot, that's not good.
Yeah.
So I've had that, and I guess it's just a matter of trial and error in your thing. Find some scrap. Don't do it on your first big project. Don't do it on the final stuff. Do it on the practice thing in the parking lot or something, right? I remember at KMWX, one of the drawings they have shows that they went from the tower above ground out to the, they took the RF out, and they had a standoff little pole like this. They had 4 ground wires around it, and the hot lead in the middle.
Called 5-wire.
Yeah, and they shot that out there as their carrier wire.
And you would not think this, but the old 5-wire, and sometimes there was 3-wire, one hot and either 3 or 4 or whatever around the outside of it, is very efficient at AM frequencies.
Yeah, wow.
Very, very little loss.
We'd like to thank Kevin for his time and his wealth of knowledge. And next time you look at an AM tower site, know that engineers respect the things you don't see just as much as the things you do. They're keeping the signal strong and the equipment safe.